Hi everyone. Today we're going to continue to learn about earth sciences. In particular, we're going to ask the question, why does the earth look the way it does? When we look around, does everything look exactly the same? No. We have mountains, we have oceans, we have valleys, we have many different landforms. In just a minute, I'm going to show you just different images of our Earth. Pretty cool pictures, right? Now, looking at all those pictures, those are all pictures on different parts of the Earth, but they all look different. I know what you're thinking. Same thing I'm thinking. How did that happen? How did they look the way they do? What we're going to focus on today is a topic called erosion. Now, erosion is the term that we use when we talk about soil or rocks moving from one place to another. I'm going to give you more examples in just a minute. I'm going to clarify erosion in just a minute, but how could rocks and soil move from one place to another? Two ways. They could be carried by wind or by water. Now, erosion is one of the causes of why our Earth looks the way it does. In just a minute, we're going to do an experiment that proves how erosion can happen with water, how water can move rocks and soil from one place to another, and where is erosion most likely to occur. For this lab, you're going to need 3 2-liter bottles. You are going to need 3 plastic cups. Clear would be best. And the material of those plastic cups, they are a little bit softer, is better. You're going to need a large container of soil, some water, dead leaves, and either a piece of sod or a plant if you have one, and you will also need some scissors. You will also need some string, 3 equal pieces to attach to your cups. The first thing we're going to do is we are going to take our 2-liter bottle and we want to turn it into this. Using your scissors, with the help of an adult, you are going to cut out a rectangle out of this bottle. Make sure you are careful and you do have the help of an adult with you. And you want to just cut into the bottle, and the bottle have lines that will actually help guide you where to cut. You want to create an opening inside the plastic bottle. The edges might be sharp, so be very careful. Now what we have created is a bottle with an opening, and you can discard this other piece. Now the next step is not mandatory, but it will make things a little bit easier. You will take your piece of string and you will make 2 holes on either side of the cup, 180 degrees apart from each other, and tie a knot so that your cup is now hanging on a piece of string so that we can use it in just a minute. Now, before we begin, let's talk about why we're doing this. Erosion is a topic that geologists, scientists that study the earth, they want to study, and they want to study right away, but it's hard to get immediate results. You have to wait years, sometimes millions of years, to be able to see a result. That's why scientists create models. And what we're going to do today is we are going to create 3 different types of models of different types of earth. These models are going to represent different types of land. Right now they're all the same, but we're going to do something different to each of these bottles. My first piece of land, I'm going to take one of my plastic cups, fill it up with soil. I'm going to add 3 cups of soil to my first bottle. And once I've added, I'm going to just even it out, flatten it out. And this bottle here represents a type of land that just has soil, nothing else. I'm sure you've probably seen that before. That's my first piece of land. My next piece of land is also going to get 3 cups of soil. It's 2 and 3. And again, I'm going to even this out, smooth it out. But the second type of soil has something covering the soil. That's where my dead leaves come in. I'm going to take my dead leaves and evenly scatter them all over the soil. Perfect. So the first land is soil only. The second land is soil covered with dead leaves. And the last land is going to be soil, but with plants planted inside of it. Now this is the part where you can decide how you want to do this. You can either pour soil in here, plant some seeds, water it, wait a few weeks for it to grow, or there's a shortcut that you can take. I'm not going to fill soil in here because that would be not fair. We have 3 cups of soil, 3 cups of soil, and I have the equivalent of 3 cups of soil here. I'm just going to place my sod. This is my grass that's been growing in the soil. I'm going to place it into this last container. This is going to be a messy lap, so better to be outside if you can. So now I have my third type of land. This is land that has soil, but it has plants planted inside. The one thing they all have in common is they all have soil. Now remember, erosion is the movement of soil or rocks from one place to another. Now today we're going to focus on erosion by water. And we're going to check to see which one of these will have the most erosion and which one will have the least erosion when it rains. Now I can't make it rain, but I can model rain. Let me show you in a minute. Now the next thing I'm going to do is place my 3 bottles on a flat surface. If they are not already, I'm going to have them hanging over the edge just a little bit. And then I will place my 3 cups on the neck of the bottles. This is what your setup should look like. And remember, we are testing the effects of erosion on 3 types of land. And we are going to test to see if water will have the same effect or different effects on these three types of land. I'm going to take a big container of water, and I'm going to pour water onto the land, into these openings, and we are going to see and test for erosion. Now, these cups that are here are going to collect the water that falls, and we are going to check to see if these lands have erosion. As the water moves, we want to see if the soil moves as well. Now, the cups will catch the water, and if there's erosion, then they will catch the soil too. The cups that are the dirtiest will have the most erosion, and the cup that is the cleanest will have the least erosion. What I want you to do is take a minute and go ahead and make a hypothesis. Make a guess. Which bottle do you think will have the most erosion? Which bottle do you think will have the least erosion? It's a good time to pause this video and make your predictions. Okay, if your prediction is done, let's get started with the experiment. The first land I'm going to test is going to be the soil only. Now my cup is hanging over the neck of the bottle, but I'm just going to hold it to make sure it's secure. Now. And I'm going to pour the water in, and we'll see. Well, the water's coming. Does the water look clean or does it look dirty? Does it look like there is erosion or is there no erosion? I'm going to stop. I don't want it to overflow, but we're just going to leave it. Let's take a closer look, and we see that there is erosion here. My cup is pretty dirty. There looks like there is a lot of soil inside of this cup. Okay, let's move on to our second type of land, and this is the land that has soil and dead leaves, and we are going to make it rain on this type of land now. Oh, didn't make sure my cup was secured. Looking at this second landform, is there erosion? Well, yeah, there is. Bring it up so you can see better. There is erosion. There is soil that has moved, but not as much as the first one. Definitely we have erosion, but much less than the soil only. This is the soil only. Look at all the soil at the bottom and at the top. And again, this one does have erosion, but not as much. Now let's go ahead and test our third landform. This is the one that has the sod, the grass, planted inside of it. Well, let's take a closer look at this last one. Does it look like there was any erosion? Not at all. Let's bring it up, take a closer look. The water is super clear. Some pieces of grass did come through, broken blades, but the water is clear. There is no erosion. There is no soil, no rocks, nothing that came through. Let's compare it to the second one, the land that had the soil and the dead leaves. Very different. Let's review what this lab was all about and our results. We started off with these water bottles that we had cut into the shapes, and we did this to create a model of different types of lands. In our first land, we had soil only. The second land had soil with dead leaves on top. The third land had soil but with grass planted inside of it. We poured water, and that water was to model rain that would normally occur. And we had these collection cups to see if erosion would occur, and if erosion did occur, how much erosion was there. In the first one with the soil only, was there erosion? Oh yeah, soil all over. We saw lots and lots of erosion. In the second one, was there erosion? There was, but not as much, a lot less. And in the third one that had the grass only, there was no erosion. Let's talk about the obvious one first. This one had the most erosion. Why? Well, soil. We touch it. It's loose. There was nothing holding it together. There was nothing protecting it from moving. As soon as I poured the water in, all of the soil came out of the neck of the bottle. You can also imagine if there was wind, what would happen here? All of the soil would just kind of fly everywhere. There's nothing holding it together, nothing protecting it. That's why we see erosion. Second bottle had erosion, but not as much. Was there something holding it together? No. But did it have some protection? Yeah. Dead leaves on top. These dead leaves kind of protected the soil from moving. Soil was still able to get out. It still moved, but a lot less than the first. Now, what about here? Why was there no erosion? Why did the soil not move at all? Two reasons. Can you guess? It had the protection on top. It had, like the dead leaves, the grass on top is protecting the top layer of the soil. But is there something holding the soil together? Yes. What does the grass have? What do plants have that go deep inside the soil and hold the soil together? That's right, roots. The roots were holding the soil together, not letting the soil escape. If we take a closer look, again, my first land, the soil is free to move all over. There's nothing holding it. In my second land, if there was wind before some rain, the leaves could move and then the water could get to the soil. But in this last one, even if there's wind, can this move? No. Let's pick it up, turn it around and show you the roots up close. The soil is all sticking together. It's not falling apart. It's not going to erode. The roots are holding it. Now, if you've completed the experiment, go ahead and fill out your observations, making sure you label everything you see. After you've completed that, what I want you to do is just take a look around you the next time you're outside, if you're traveling somewhere, and look for different landforms. Try to think what would happen if there was rain here. What if it was light rain or heavy rain or even a flood? What if there was heavy wind there? Could you see how wind and water could change the land and make it look different?